All right, last night we gave you these practice problems. We did a couple of these in class. We worked together. Ms. Glick worked this out. So I just want to go over each one so you guys can see. You guys have to be able to do this on your test on Thursday. You're going to have a couple graphs, and it's going to say, tell me the domain, the range, the increase, the decrease, the constant, f of this, f of that. You guys have to be able to find all this information from a graph. As far as mathematical computation goes, there's really only probably one problem, which would be from your quiz, 1.8 stuff, that you guys have to do a lot of math computation. But as far as like a lot of adding and subtracting that stuff goes, that's not really what these sections are about. This stuff is not the easiest thing in the world, I understand that. So we need to really make sure that we pay attention to everything that's on a graph. For domain and range, guys, if you have a closed circle, what does that mean? It means the value is included. Excuse me. It means the value is included. It means you have to have a bracket on your answer. If you have an open circle, what does that mean? It's not included, so you'd have a parenthesis. Anytime you have infinities, what do you know? It's a parenthesis. If you notice here, guys, on intervals of increase, decrease, and constant, where do we read that always? On what axis? The x-axis, good. The y-axis does not matter. And you always use parentheses. Never a bracket. Always, always, always parentheses. Again, looking at this one. What do you notice about the ends of this graph? I know we did this one yesterday, but I want to talk about each one of them. What do you notice about the ends of this graph?
Arrows.
There's arrows on both ends. That means forever it's going to get wider, and forever it's going to get taller, longer. So that's why your domain and range are negative infinity to positive infinity here. Again, we read intervals of increase and decrease on the x-axis from left to right. From where to where is the interval, is your graph decreasing? From where to where is it increasing? From where to where is it decreasing? That's what matters the most, guys, is that you understand that this is on the x-axis. It's not how high or how low the graph goes. It's the interval over which the increase or decrease is happening. Right? Does that make sense? Okay, let's go. Check number 3. What do you notice about number 3? Just upon looking at number 3, you can tell a lot about this graph. First of all, are there any infinities?
No.
No, because you don't have any arrows. Do you have specific starting and stopping points that are included? Yes, so you should have brackets on your domain and range. Do you have any areas of constant where the graph does not change at all, just stays flat? No. So those sorts of things, you guys need to look at each graph and say, is this continuous? Are there any breaks? Do I have any gaps where I'm going to have a union or something like that in my domain or my range? But if we look over here, again, same thing. I have a specific starting and stopping point. So I have brackets on my domain and my range. My intervals of increase and decrease and constant are read upon the x-axis. From where to where on the x-axis is this increasing? From 2 to 4. Where is it decreasing? From 4 to 7. We always read from left to right. Does that make sense? Okay. What do you notice about this one? This is different from the other ones. Why? Tell me. Sure. What do you have a question on? Anything you just want to look at it. That's fine. Yeah, that's fine. No, that's fine. What do you notice about number 5? What do we have at either end? There's arrows. That's a negative infinity to positive infinity. It's forever going to get wider and forever going to get taller. Our interval of increase, decrease, read on the x-axis from left to right. Same thing with number 6. Again, I see how it's like negative 3.25, that sort of thing. On your test, it'll be whole numbers so you can tell. You won't have to estimate. Yesterday, I told you guys you could put ish on these. The reason why is because it's not 100% right on a whole number. Does anybody have any questions? Yeah.
Can you go to the piecewise function?
Yes, we're going to do those in a second. We're going to do both of them. All right, let's next ones. All right, so very similar to the last couple that we did, number 7 here. Arrows on both ends, so negative infinity, positive infinity. You're seeing where it goes up and down and up again. Again, you're looking at the x-axis. From where to where is the interval increasing? From where to where is it decreasing? And I'll post this as soon as we're done in a second. I'll post this video so you guys can see the answers. Number 8, we have specific starting and stopping points. Do I have an area of constant on this one? Yes. The area of constant was where the graph is horizontal, where it's flat. There's no change. There's no rise. It doesn't go up any. It doesn't get any steeper. It doesn't go down any at all. It just stays the same. That's your area of constant. Does anybody have any questions about those graphs? All right, we're going to look at your review in a few minutes, and you guys are going to see just different kinds of graphs you can see. There's all sorts of different kind of graphs that you're going to see. Everybody's going to have a different one to look at. So it's important that you understand what you are looking at. Let's look at the piecewise functions, okay? We're going to do these two together. You guys cannot look at this and do it all in your head and just draw the graphs perfectly on your paper. If you need to bring in color pencils, bring in color pencils. If you need to bring in extra erasers, bring in extra erasers. Whatever you guys need to do. But I need to see some work for this. If you notice number 1, how many different graphs are you going to have on one coordinate plane? 2, okay? So before you start anything, kind of survey the situation, right? F of x is a fancy way of saying what? Y. This is just y equals. You guys can tell me a lot about these two graphs that you're going to draw. First of all, what shape are they going to make? They're both lines. This is both to the first power. God bless you. Are they both positive lines or both negative lines? Negative. What kind of a dot are you going to have right here at your boundary line? Close. Why? Because it's or equal to. What kind of a dot are you going to have here at this boundary line? Open, because it does not include. All right, all those things are very important. A lot of points goes into a graph like this because there's a lot of different little pieces. So I'm going to come down here and I'm going to write two separate equations. Y equals, what was it, negative 2x minus 1? Negative 2x minus 1. And then over here I have y equals, is it negative x plus 4? Okay, so those are my two graphs. So I'm going to tell myself all the information I know just by looking at this. My slope is what? Negative 2, so negative 2 over 1. And what's the y-intercept? The y-intercept is at negative 1. So draw yourself a little picture, because this is where some of us get confused. We don't know when we go up 2, we don't know which way to go over 1. My line is sloping downwards. It's a negative line. So you should have your y-intercept at negative 1, and your slope is 2 over 1. It doesn't matter if you guys go up 2 and over 1 or down 2 and over 1. You need to know the direction. Your line should be sloping downwards, so that should be in your mind. You should think, okay, when I go up, which way do I go over? So I'm going to go up 2 and to the left 1. Then I'm going to go up 2 and to the left 1 again. Up 2 and to the left 1 again. Down 2 and to the right. Down 2 and to the right. We are creating our downward sloping lines. Everybody see that? Yeah? Okay, so now if I connect my dots, and I'm going to use a dotted line. Why am I using a dotted line? Because I'm going to erase some here. Now that I have my picture of my graph, I look at what my boundary line would be. Where is the vertical line I'm going to draw? At x equals what? 2. At x equals 2, right here. So this inequality says I want all of the values that are less than or equal to 2. On the x-axis, where are the values less than or equal to 2? To the left. All the stuff over here. So that means I want to keep all of this stuff over here, and I want to erase what? The other stuff. So I want to keep everything over here, and I want to erase anything to the right. And that before I finish and move on to the next one, what do I have to look at? What just happened there? That's weird. Is it a closed or an open circle? What did we say it was? Closed. Why is it closed right there? Because it includes. It's or equal to right there. Good. So now I'm going to look at my next one. Negative x plus 4. So talk to yourself. My slope is negative 1 over 1, right? My y-intercept is at 4. And my line is going to be sloping downwards again, okay? So I'm going to go up to 4. 1, 2, 3, 4. And it's down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then when I connect my dots, it's something like this. When Bobby gets back. Where is my division line that I'm going to look left and right of? Yes, sir. Yeah. Yeah. If you want to make a table of values, that's fine. Where's my division line? Where there's a line. When Bobby gets back, then Ozzy's going, then when Ozzy gets back, you can go. Where's the division line? At x is greater than what? 2. So I'm going to go right here to 2. And I want all the values that are what? Greater than 2. Where are the values on the x-axis greater than 2? To the right. All this stuff where? Over here. I want to keep that stuff. And what do I do with everything else? I'm going to erase it. I'm going to erase it. So once I erase, I then have to look and say, okay, well, what kind of a dot should I have there at that boundary line? What kind of a dot should I have? Open. I should have an open dot. If you guys aren't sure if I can tell if it's open or not, right? If you're not 100% sure, don't raise your hand and say to me, can you tell this is open? All right, draw yourself an open dot, and then if you need to say like, oh, this one's open, that's fine. If you need to say, hey, don't forget this one's closed, that's fine. Whatever you need to do to let me know. But your piecewise function, however many equations are there, that's how many graphs you should have, and you should have pieces of all of them. You should not have an entire graph. Does that make sense? All right, let's look at number 2. Number 2 is a little bit harder. Number 2 is a little bit harder for a variety of reasons. First of all, why is 2 harder? Tell me something you see. There's 3. Okay, good. What's another reason 2 is a little bit harder? Do all 3 of them make straight lines? No. Which one does it? X squared. Makes a problem. All right, you can't just plot the y-intercept and the slope and tell me, oh, this is what it's going to look like. You guys actually have to make a table of values. So again, remind yourself, f of x is a fancy way of saying y. So my first equation says y equals negative 4. This is the easiest graph to do, but it's the one we mess up all the time. Where is y equals negative 4? 4. At negative 4. And then what does that line look like? God bless you. It's a horizontal line. It's a horizontal line right here. And so now I say, okay, well, what is my boundary line? Where do I look? And what kind of a dot do I have there? Where do I draw my boundary line? At negative 2. And I want all the values on the x-axis that are less than negative 2. Where is that? To the left. Watch, look, you can look at your inequality sign and it'll tell you which way you want to look. It's pointing this way. So I want everything that is less than or equal to, right here, less than or equal to, negative 2. What kind of a dot do I have at my boundary line? Closed. Why is it closed? Because it's or equal to. So everything else is gone, and you have a solid dot at right here, or equal to. So then my next function says y equals x squared minus 2. Anybody know what, in your mind, what kind of a shape that should make? A U. Good. Now, this is where you're going to need to make a table of values. You have x values, you have y values. I'm going to do negative 2 to positive 2. If I plug in negative 2 squared, guys, what is negative 2 squared? 4. And 4 minus 2 is? Okay. Plug in negative 1. What's negative 1 squared? 1. 1 minus 2 is? Negative 1. What's 0 squared? Minus 2? Negative 2. What's 1 squared? Minus 2. And then 2 squared? Minus 2? 2. So when I plot these points, I have a point at 2, 2. Negative 1, here, here, and here. So I'm going to draw my graph. It's going to be a a U, nice smooth curve. And now I look at my boundary line. Where do I draw my lines? And what kind of dots do I have there? Where is X in this inequality? In between where? -2 and +2. This one's really easy to do because you can see the values that you want. You want all the values in between what and what? -2 and +2. You want to keep this stuff here. And what do you do with everything else? You're going to erase it. Good. You're going to erase. Good. And then the last thing, Gus, what do I need to do? Make them an open circle. Why are they both open? Because it doesn't have the or equal to. So make your circle however you need to let me know, hey, this one's open, this one's open, right? And then you have your last. Your last is y equals -2x plus 4. Now, Gus just asked a question a second ago. He said, can you just plug in points? Absolutely. If you don't want to use the slope and the y-intercept, you can plug in points. That's fine. But it should be exactly the same. Here, I'll do it with you. Hang on. So my slope is -2/1, and my y-intercept is at 4, right? It's at +4. So it's a downward sloping line. So I'm going to go up to 4. I'm going to go down 2/1, down 2/1, down 2/1, down 2. Okay, just keep going. Down 2/1. I'm going to draw our line here. Now, what is my boundary line? I'll go over it with you in 1 second, guys. What is my boundary line, and where do I want the values?
2.
Okay, my boundary is at 2, and I want everything that's what?
Greater.
Greater than. Where are the x values greater than?
Right.
To the right. So I'm going to draw my line of what I want to keep. So all right here. I'm going to erase the other stuff. And then what kind of a line or dot, I'm sorry, do I have it to? Why is it closed? Because it's or equal to. Good. So I have a closed dot right there. Did not mean to erase part of my line. So there is what your piecewise looks like. You have 3 different graphs and you have 3 different pieces. Gus, what points did you plug in?
3, 4, 5.
So x is 3. So -2 times 3 plus 4. So -6 plus 4, -2. So you had a point at 3, -2.
I didn't have the point on 2.
So there's a 3. Oh, okay, but the rest of them should all fit. Okay. If you're going to plug in points, that's perfectly fine. Just start with whatever the boundary is. Yeah. And then that'll be easier for you to see. Questions? All right, I'll post these answers worked out in the module so you guys can look over them again. So you guys can see that. I need you to please pull up, if you guys could pull up the review. I'm going to look through the review with you for a second, but there's 2 changes I want you to make just so things are a little, they fit on the graph better. Everybody pull up the review. I want you to go to numbers 5 and 6. Pull up the review and go to numbers 5 and 6. Everybody with me? Come on. If you look at number 5 right now, I want you to change -3x to +3x. Make this a +3x. +3x. Change that -3x to a +3x. It'll fit on the graph better. On number 5, change -3x to +3x. And then over here on number 6, I did not mean for this to be 2/2. It should be 2/3. That is my bad. When I was typing it up, it should be 2/3. So 2/3, like that. So on number 5, you changed -3x to positive, so it fits better on the graph. And then on number 6, fix this. It was 2/2, change it to 2/3. You're going to have at least 2 piecewise functions on your test. So it's really important that you guys are on top of what piecewise means. But you will have at least 2 piecewise. You cannot just look at it. You guys cannot just look at it and just put it all on the graph. There's so much that goes to a piecewise. You need to take each equation, graph it separately, check your boundary line, left or right, what you're looking for. Do you want an open or closed circle? Whatever you need, you guys have got to take your time and go through. Does everybody understand? All right.